Now, for the next piece, they want us to compute the point estimate using two different methods. Okay, well, there is the definition, which was on the previous page in the gray box. It tells us that the point estimate is x bar 1 minus x bar 2. Okay, so the point estimate is x bar 1 minus x bar 2. So we just need to find the means of our two groups, our tea group and our coffee group. Luckily for us, we have StatCrunch. So I can say to it, hey, StatCrunch. Actually, I can see it right here as well. It's right there, but that's okay. I want to prove it to you. So stat, summary stat, columns, little review. I click T and a control click or command click if you're on a Mac, and coffee, and I want the means because that's what X bar is. It's the mean. So I say compute and I get these two numbers. So it's 34.8182 take away 17.7. So then I would grab Desmos really quickly, and then I would find that subtraction. So 34.8182 take away 17.7, and sure enough we get 17.1182, which if we look was exactly what it was saying it was right here. So it's 17.1182. Now I know what you're thinking. You're thinking, well, that's a second method right there, just to look at the output. Yes, but that's cheating. So we're going to come up with a different method. A little review. So remember that we also learned back in chapter 9 that a point estimate for a confidence interval like this is the lower plus the upper divided by 2. So it's sort of a cheating formula. So the point estimate, it's not the official formula. The official formula I've actually blocked because it's so tricky. But this is a way to kind of get around it. Because the way our confidence intervals are constructed, we know that the point estimate will be in the middle of the interval. So if you take your lower number and your upper number and you add them up and divide by 2, you'll have it. So if I take negative 0.1974 and I add 34.4337 and I divide by 2, put it in parentheses so that you do it correctly. All right, so let me grab Desmos. So negative 0.1974 plus 34.4337. Put it in parentheses and then divide it by 2. The other way to do it is to divide by first, hit the division first, and then that will make the fraction, and then divide by 2 down here. So either way, we're going to get 17.1182 approximately, which is what we thought on the other method. So this was just a little review of another way to find point estimates for a confidence interval. Now, how about finding the margin of error? That's also a review. So I guess we can make a little note. This is a review. The margin of error, we also learned a little kind of cheating formula for it, right? So remember, all this is based on, let me just draw the picture right here. You have your lower over here, you have your upper over here. Your point estimate is in the middle. So if you add the 2 and divide by 2, you will find the center. And then the error is this distance right here, or this distance right here. So the way to find that is to take the upper minus the lower. So the margin of error is the upper minus the lower divided by 2. Now this is going to be a little tricky because this has a negative in it. So you're going to say it's 34.4337 minus negative 0.1974, all divided by 2 like that. And put it in parentheses. Okay. So if I go back, the problem with this method that I have here is that it's in backwards form. So I'm going to hit 34.4337 first, then minus negative 0.1974. And I'm going to divide it by 2. And again, you could put that numerator in parentheses as well, right? So if you start the parentheses here, it ends there, and that would also work. So it's 17.313. 0.56. And for the record, these would all be units per milliliter. That was the units for this particular item. So here's this point estimate. This would be units per milliliter. That would be the margin of error, and that's its unit. And this would be, point estimate. Units per milliliter is the units for the point estimate, and this is the margin of error down here. Units per milliliter. Like that. Now, how to interpret it? Well, we always know how to start these. We are 95% confident that the true, and then you have to say what the population parameter was. Well, the parameter is the difference between the independent means, right? It's the difference in means. So it's the true difference in means, or difference in mean interferon levels between coffee and tea drinkers. Is between negative 0.1974 and positive 34.4337 units per milliliter, right? We always go back to the lower, right? This is the lower and this is the upper. The hardest part on these is this piece in the middle where you're explaining what this was about, right? It's the difference in average. You could use the word average. I'll just write that right here. Average interferon levels between coffee and tea drinkers, right? That's the context. That's the hardest part, right? And the parameter as well, right? The parameter is the difference in the means. So you have to kind of put the difference in the means and the context together. But the rest of it's kind of straightforward. Okay, now, is there a significant difference between coffee and tea drinker interferon levels? Now remember what that goes with. The null hypothesis is always that there is no change, right? So the difference piece. Okay, so the null hypothesis would be that there's no change. Mu1 for the tea drinkers is equal to mu2 for the coffee drinkers. In other words, mu1 minus mu2 equals 0. That's what no change is, right? No difference, no change. Okay, so look at our graph. If we look at our lower number and our upper number, the upper is 34.4337. The lower number is negative 0.1974. 0 is here. It's inside that interval, right? The interval is anywhere from the lower number to the upper number. And for the record, the point estimate is right here in the middle at 17.1182. Right? That's the point estimate. This is the lower. This is the upper. All right, so this interval contains 0. 0 is between the negative 0.1974 and the positive 34.4337. So that means that there is not a significant difference, right? If 0 is within the interval, there is not a significant difference. Right? And within the interval, what that means is between the lower and the upper, right? Between the lower and upper confidence interval limits. If 0 is not in the interval, then there is a significant difference. All right, so let's look at our example. 0 is between the two numbers, So no, this interval contains 0, which implies there is not a significant difference. Oop, which. I made that into a G for no reason. Which implies there is not a significant difference in interferon levels between coffee and tea drinkers. I'm probably writing a little too much down there, but I want to make sure everybody understands the context, right? But it's all that the interval contains 0. That's the key. The interval is containing 0, therefore there's not a significant difference. I know that's the same thing we've seen in the last 2 sections, but we just want to stress it one more time.